Hello good dear viewers. In this tutorial we are going to find a solution to this amazing radical equation. We would like to find the real value or values of x that can satisfy the equation the square root of 3 plus square root of x plus 9 equal to the cube root of x. Before we start finding the solution, let us talk about the domain. For the cube root function, the radicand can be any real number from negative infinity to positive infinity, so we have no problem with this one. But what about this one? It has to be greater or equal to 0. Already we can see that this is a positive number, so we have no problem with that. So this one has to be what? Greater or equal to 0. That is x plus 9 will have to be greater or equal to 0. That is x greater or equal to negative 9. So if you combine the two together, it implies that we have to get a number which is greater or equal to negative 9. Let's get started. This equation is a little bit confusing, so let me use substitution. Let u be equal to x plus 9, which is this one. And what will be the value of x? X will be equal to u minus 9. So this is what we need to substitute. So it will be the square root of 3 plus square root of what? U to the left hand side, and this is equal to the cube root of what? X, but x is u minus 9. U minus 9. To get rid of the cube root, we have to cube both sides. Raise both sides to the power of 3. Raise this to the power of 3, so that this will cancel this. But what happened to the left hand side? It will be square root of 3 plus square root of u times square root of 3 plus square root of u times square root of 3 plus square root of u. And this is equal to u minus 9. Because it has a power of 3, therefore we have to raise this one to the power of 3. It means we should take the base and multiply by itself in 3 places. So if you consider the first two here, we have the square root of 3 plus square root of u squared, because there are 2, right? Then times the other one, which is square root of 3 plus square root of u, and this is equal to u minus 9. We are moving. This will cancel this, so we have 3 plus square root of u here times square root of 3 plus square root of u, and this is equal to u minus 9. Now I would like to divide both sides by 3 plus square root of u. If you do that, you're going to be left with 3 square root of 3 plus square root of u to the left, and this is equal to u minus 9 divided by 3 plus square root of u. Again, I would like to square both sides. Square this, square this. The power of 2 will clear this square root, so this will cancel this. What do we have left? We have 3 plus square root of u, and this is equal to u minus 9 squared divided by 3 plus square root of u also squared. 3 plus square root of u is equal to u minus 9 whole squared divided by, I would like to expand this one first. First term squared, 3 squared is 9, plus 2 times 3 is 6, times this will be 6 root u, then plus square root of u squared, that will give us u, right? And again, I would like to do another substitution by let me take another variable. Let's use m equal to square root of u. So therefore m squared will be what? Just u. So this is the substitution I would like to make here. Therefore to the left hand side we have 3 plus what? M. So to the left hand side we have 3 plus m, because we have let square root of u to be equal to m from here, and this is equal to the top we have u minus 9 squared, but u is m squared. We have m squared minus 9 whole squared, right? To the bottom we have 9 plus 6m plus m squared. So 9 plus 6, you know we have square root of u here, but we have let it to be equal to m, so we have 6m plus, we have u, which is now m squared. So we have m squared here. Squared. So let me further break it down. We have 3 plus m equal to, this is difference of two squares that can be factorized as m minus 3 multiplied by m plus 3, right? If you expand this, you have to get m squared minus 9, definitely. But remember, it is raised to the power of 2. And this one can also be factorized because it is a perfect squared. Just look at it. 6 divided by 2 is 3, and 3 squared is 9. Therefore, this quadratic expression is a perfect squared, which can be factorized as what? M plus 3 whole squared. This is 3 plus m, or I can write it as m plus 3, all the same, m plus 3 equal to, you can distribute this exponent to these two factors. So we have m minus 3 squared times m plus 3 also squared, divide by what? M plus 3 also squared. Just look at it. This will cancel this. We only have m plus 3 equal to m minus 3 whole squared. So let's expand the right hand side. We have m plus 3 here equal to m squared, that is the first term squared, minus, because of that minus sign, 2 times m times 3, that is 6m, then negative 3 squared is positive 9. Now let us take every single term to the right hand side. We have m squared already there. Negative 6m minus m is negative 7m, minus 7m. Then 9 minus 3, I think it's 6, yes, plus 6. This is equal to 0. This is a quadratic equation that can be factorized. Two numbers that can be multiplied to get 6, but when you add them together, you get negative 7. They are negative 1 and negative 6. So m minus 6, m minus 1. These are the numbers, right? Because negative 6 times negative 1 is positive 6. Negative 6, negative 1 is negative 7. If you solve this, you have m either equal to 6 or m equal to positive 1. So we are going to do a kind of back substitution. What can you remember about m? M is here. Let me just copy this. You can see that m is equal to square root of u, but m squared is u. So therefore, we can find u by squaring these two numbers. So since m squared is equal to u, therefore 6 squared is equal to u, or the other one, 1 squared is also equal to u. So you can see that u can be 36, or u equal to 1. Another back substitution. What can you remember about u again? Remember that we substituted u with something here. Can you see that? X is equal to u minus 9. But x is equal to u minus 9. Therefore, x is either equal to 36 minus 9, or another u, which is 1 minus 9. So you can see that x is either equal to 27 or x equal to negative 8. But we have to test them in the main equation. Remember, if you are solving a radical equation, you could obtain an extraneous solution, a real solution, or what? An imaginary solution. So let's take the original equation. I think I can even write it up here. The original equation was the square root of 3 plus square root of x plus 9 equal to what? The cube root of x. So let's start by plugging in 27. If x is 27, we have the square root of 3 plus square root of 27 plus 9 equal to the cube root of 27. If the left and the right hand side are exactly the same, then we conclude that x equal to 27 is a solution. 27 plus 9 is 36. Square root of 36 is 6. And 6 plus 3 is 9. Square root of 9 is 3. So the left hand side is 3. And we know that the cube root of 27 is 3. And hence, x equal to 27 is a solution. So what about when x is equal to negative 8? Negative 8, negative 8. Negative 8 plus 9 is positive 1. Then square root of 1 is 1. Then 1 plus 3 is 4. Square root of 4 is 2. Equals cube root of negative 8 is negative 2, which are not the same. And hence, x equal to negative 8 is not a solution. And hence, we have to consider that x equal to 27 is the only valid solution here. And therefore, x equal to 27 is our only solution. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.